Hi students, welcome to my YouTube channels. Today my topic is psychometric problems. So psychometric problems formula based problems only. If you know formula, you can solve the problem. So psychometric problems, how they will give. Problem looks very simple. The atmospheric air has a dry bulb temperature 21 degrees Celsius and the wet bulb temperature having 18 degrees Celsius, 21 degrees Celsius, 18 degrees Celsius. And barometric pressure they given 750 mm of Hg. Then they are asking determine the partial pressure of water vapor, relative humidity, dew point temperature. May they will ask degree of saturation, enthalpy, all those things. So here they are asking only three unknowns. So how to attempt these problems? So see here first given data I wrote. Dry bulb temperature they given, wet bulb temperature 18 and barometric pressures they given. Some symbols I wrote. PS, partial pressure of water vapor at saturated conditions. PW, saturation pressure corresponding to the wet bulb temperature. So PW will get from the wet bulb temperature. PS will get from the dry bulb temperature. So to value how to get will write from the table. I wrote here table. The table will be there in the refrigeration and psychometric chart. This table is available in the last page. So temperature and vapor pressure in bar. This temperature will start in, we will see the table minus 40 degrees Celsius to 50 degrees Celsius. So corresponding all the vapor pressure will be there. Here I taken 15 to 22 because I need in this problem this range value I need. So I wrote for that only. So, okay. So partial pressure of water vapor formula what is PW minus PV minus PW, TD minus TW, 1544 minus 1455 minus 1.44 TW. So TD and TW dry bulb temperature, wet bulb temperature. This should be in degree Celsius only. This value will substitute here degree Celsius only. This also TW wet bulb temperature. That also degree Celsius only will take. So for this, what are the unknown? PW unknown, PB unknown, and other things are known. So PW and PB unknowns. PB is already given 750 mm of Hg. But all the values will given in the bar. So this will convert into bar. So how will convert into bar? You listen here. I know 760 mm of Hg is equal to 1.01325 bar. This value we know, standard value. Barometric pressure 760 mm of Hg. If you bar na 1.0132. How to remember this value? No need to remember. These tables already I told. Psychometric and refrigeration psychometric tables. They given thermodynamic properties of the saturated air atmospheric pressure of 1.01325 bar. This value given. So I need 1 mm of Hg. So we can calculate now. 1 mm of Hg is equal to, how will calculate? The 750 will divide here. 1.01325 divide by 760 mm. So if we divide, how much value will come? Just we'll calculate and we'll check. 1.01325 divided by 760. That value is coming 10 power minus 3. So that means 0.001. For 10 power minus 3 there. Then how many value? 3, 3, 3. Then 2, 2, 3, 6. So 6 digit I taken. After decimal taken 6 digit. Why will you stop here? See the table, all the value given 6 digit. 1, 2, 3, 4, 5, 6 digit. So we stop from here. See if you will take also this value, very minor difference will be there because very small value. If you will take after 6 minus 10 to power 6, 7. So very small value. So okay, we ignore this value. Remaining value will ignore. So now this is value of the 1 mm of Hg. This value nothing came 1 mm of Hg. This is called conversion factor. If whatever value they will give in this problem less than 760, multiply this value, will get the PV value. If some problems barometric pressures they will not give. They will not give we'll write this value only. Bar directly 1.01325 bar PV value directly will substitute. If they given anything less than 760, will calculate like this. So now we know the PV value. PV value, what is PV value here? 750 given. Mm of Hg, mm of Hg na 0.001333. So remembering also why if you are keeping only Other digit I not taken, remembering also very easy. 0.0.001333 you take. If you multiply this, it will come 0.99975 bar. Just we'll check it, this value. 750 into 0.001333. So we are getting 99975, correct. So PV value we got this. Now PS and PW value, corresponding temperatures will get the value. So PS value how will get? At 21 degrees Celsius. That means from the dry bulb temperature, PS value will get from the table. 21, what is their value? 0.02487 bar. Then what is PW value? Corresponding temperature at 18 degree from chart, from table. What is 18 degree? 0.020.02064 bar. This value will take from the table, psychrometric table. From psychrometric table, these two value will get. So okay, this value always will take from the psychrometric table. PS corresponding to DBT, dry bulb temperature. PW corresponding to wet bulb temperature. Corresponding to wet bulb temperature will get the PW. So now all the value I know. Now whatever unknown will be there, we can calculate. So PV we calculate now. So PV is equal to what is PW. PW corresponding to the wet bulb temperature. You write here 0.02064 minus, take the bracket, PB value 0.99975 minus PW 0.02064. Then TD, dry bulb temperature 21 degrees Celsius. WBT 18 degrees Celsius. So that value I already told will keep in the degree Celsius only. This value will keep the only degree Celsius only. 1544 minus 1.44 and 18 degree. What is this one? WBT. TW symbols I taken WBT. This we can take the symbol TD. This can TW. Okay, dry bulb temperature, wet bulb temperatures. Okay, now if we'll solve this, we'll get the PV value. Already we calculated. So PV value we got 0.018705 bar. We got this value. PV value we got now. One value over PV value now you know. Now here relative humidity 5 degree of saturation. So relative humidity value how we'll get? This 5 formula will be PV minus PS. This formula will be PV minus PS. So PV value just now we got 0.018705 divided by PS value 0.02487. If we'll calculate this value is coming 0.7521. This value getting 7521. So relative humidity also you can write percentage, so 75.21 percentage. So we got two values. Now what we have to find out? Dew point temperature. Dew point temperature now we have one specific method, interpolation method. We can calculate the dew point temperature. You see how we'll calculate. So PV value, the dew point temperature value will get corresponding to partial pressure of water vapor. So water vapor, how we'll calculate? What is the method? PV value we got just now here, right in the middle, 0.0018705. You write the middle. And we'll see this vapor pressure, partial pressure of vapor pressure belongs to where? Exact value will not be there in the table. Exact value will not be there table. Then that value will be there in between some temperature. So 187, you see here, 170, 181, 193. That means this value belongs to between 16 and 17. This value belongs to between 16 degrees Celsius to 17 degrees Celsius. This value belongs to 17 degrees Celsius. Now, what is the 16 degree value? 0.018181. What is 17 degree 17 value? 0.01937. Now look again. Once you are going to find the dew point temperature will calculate based on the partial pressure of water vapor. So partial pressure of water vapor will check in the table where it belongs. So this value belongs to in between 16 and 17. See here 187, here 181, here 193. So that means in between 16 and 17 this temperatures belongs. Partial pressure of water vapor corresponding temperature will be in between 16 and 17. So we know the answer is dew point temperature. Answers we know 16 plus some fractions value around. So how we'll get the some fractions value? We'll calculate this. Suppose this take A point, B point, this is called C point. You take this, write this formula I am going to write. So this is A, this point is A, this point is B, this point is C. So what is the value, fractions value, how we'll calculate? So we'll calculate, fractions value will calculate B minus A and C minus A. B minus A and C minus A we can calculate. So what is B value here? 0.018705 minus A value will be 0.018181 divided by C 0.01937 minus A value 0.018181. If you calculate this, you will get 0.434. That fractions value we are getting how much? 4.34. Just add this plus 4.34 na 0.434. 434 degrees Celsius. So this is called dew point temperature. So this way we can calculate the dew point temperature. This is the solution. So psychrometric problems, if you will see, these problems will be very simple. So okay man, once you are seeing this video, just you subscribe this. If you will subscribe, then only you will get the new problems. Once I will upload now, you will get directly message in your system, okay, or laptop, whatever. Okay, thank you.